a warm-up, right? A marathon has 3 scattered starting times, each called a wave. I don't know if anybody in here has ever run a marathon, but like they put you in order based on your entry time. And then each wave has 5 starting areas called corrals. That's where you stand with all the people who are around your time that runners are grouped into. Draw a tree diagram that shows the possible waves and corrals the runner could be assigned to. So what we have here is wave A, B, and C, right? You should be doing that on your iPad, A, B, and C. And then each wave has 5 groups of people. So within each wave, you are grouped again by more specific entry times. So that's our tree diagram. How many different wave and corral assignments are there? So remember, we can use the counting principle. We take the number of the first category and we multiply it times the number of the second category. Or you can count up each individual combination. So how many would there be? 15. And then what would be the probability of being in wave B, corral 5? How many of those are there? There's only one. There's one wave B, corral 5. Okay, so that's just a review, right, of a thing happening. Now we're going to jump into compound events. We talked about these a little bit. A compound event is when we take 2 probabilities and we multiply them. That way we don't have to do all the tree diagrams for all the days, right? We're going to first talk about independent. That means they don't affect each other, right? We talked last week about independent, and then dependent is when the first one does affect. We had that example with the socks in the drawer. Guys, there are several of you with earbuds in right now, and it's just kind of rude, so take them out. Thank you. Jackson, both of them? Okay. Okay. Okay, thank you for confirming. All right. So let's go ahead and practice independent events, right? So we multiply the probability of the first by the second. So let's look at this scenario. What's the probability of rolling a standard die twice and getting an even number, then a 5? So what's the probability of getting an even number the first time you roll the die? 3 out of 6, or 1/2, yep. And how about what's the probability of getting a 5 the next time you roll? 1 out of 6, right? So when we multiply those together, there's a 1 in 12 chance that you would roll an even number and then a 5. If this could have been simplified, we would have simplified. We always simplify. Okay, what's the probability of tossing a coin, flipping a coin 3 times and getting tails each time? So let's figure out each individual probability. What's the probability of getting tails the first time? 1/2. What's the probability of getting tails the second time? 1/2. And the third time? 1/2. Yep. So what's the total probability of getting tails each time? 1/8. Yep, 2 times 2 times 2 is 8. So I tried to draw a tree diagram of what that would look like up here on the board. Right. So the first time you'd get heads or tails, and then each of those you'd get heads or tails, and then you'd have heads or tails again. And so there's only one time where it's all tails out of 8 possible combinations, right? But we can shortcut it by just in our mind knowing and then just multiplying each of those. Okay. All right, let's look at this A, B, C, and D. These are all related to these 2 spinners here. Notice we have a spinner that has the numbers 1 through 12. Some of them are shaded. And then we have a spinner with red, blue, green, red, green. Okay, so we're going to answer these probabilities. What is the probability of spinning an 11, then red?
1 and 2.
So we have 1 out of 12 for 11, and then what's the probability of spinning a red?
1/5. I mean 2/5.
Yep, 2/5. So when we multiply these, we get 2 out of 60, which can simplify to 1 out of 30. Always simplify. Somebody disturbed by that number? I don't like to have someone upset. Addison, you okay?
Yeah, I'm sorry.
Okay. All right, how about the probability of unshaded, then green? So how many of these are unshaded values?
8.
8 out of 12. How many greens? 2 out of 5. And this is where we can cross simplify, right? 2 can go into both of these numbers. 2 divided by 2 is 1. 12 divided by 2 is 6. So I get 8 out of 30, which can simplify to 4 out of 15. How about the probability of at least 3, then blue? So how many values are 3 or greater is what they're asking for.
9.
So it can be 3.
That can't be 3?
It can.
Yeah, 9.
So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because we're including that 3, right?
I forgot about this 12.
That's okay. So we have 10 out of 12. And then how many of these are blue? 1. So again, I'm going to cross simplify. I'm going to get 2 out of 12, which simplifies to 1/6. Okay, this last one, probability of getting an even and shaded number. So how many of those on this spinner are even and shaded?
2.
Yep. 2 out of 12. And then not red. How many of these are not red? 3 out of 5. And again, I'm going to cross simplify, and I'm going to get 2 out of 20, which simplifies to 1/10. So this next 2 questions has to do with a deck of cards and a date in the month of June. There are 30 days in June. So what's the probability of getting an ace out of a deck of cards?
1 out of 52.
4 out of 52. And how many odd numbers are there if there are 30?
30.
15 out of 30, which simplifies to 1/2. So these can cross simplify. So I get 2 out of 52, which simplifies to 1/26. Everybody remembering this, right? You multiply, you find the 2 probabilities. Sounds familiar? All right, how about a spade and then a multiple of 4 from those date options? So how many cards are considered spades in a deck of cards? 13 out of 52. We can simplify that to 1/4 because 1/4 of the deck is going to be spades. And how about a multiple of 4? How many multiples of 4 are in the numbers 1 through 28? 7. Right? So we can't cross simplify here, so we get 7 out of 120. So those are independent compound events. Now we're going to flip the paper over. So you guys are just going to scroll up. I'm going to turn my paper over. And we're going to look at dependent compound events. So we're not going to do these up here. We're skipping this part. And we're going to scoot down here to dependent. Remember, this is when something does affect the second event, right? Not replacing that sock changed how many socks were still in a drawer. Does that sound familiar? Kinda? little bit. Okay, so our first example has markers in a pencil box. A marker is drawn, not replaced. Underline where it says not replaced. Or highlight it. You guys have highlighter options, right? Right, Brody? Mm-hmm. All right, so we're going to figure out what's the probability of picking out a red marker and then a blue. So there are 25 markers in that pencil box. So how many of them are red?
4 out of 25.
Yep. And then what's the probability of picking a blue marker out of the ones that are left? The red one is no longer in there.
4 out of 21. Right?
12 out of 24. Right? 12 blue. There's only 24 markers left. So I can cross simplify, and I'm going to get 12 out of 150, which simplifies to 2 out of 25. Right. So not a great chance that you would choose red and then blue. But because there's, now is there equally likely chance of pulling the same color or pulling different colors? No. Why not? They're not all the same number, right? We don't have the same number of green, yellow, red, and blue markers. Okay, how about what's the probability of choosing yellow then green?
6 out of 25.
We restart. All the markers are back in the pencil box. So we have 6 out of 25 that are yellow,
3 out of 24.
and then 3 out of the 24 left are green. I'm going to cross simplify here. You okay, Addison?
Yeah.
Yeah, you had a big weekend. I saw that on the Facebook. What? Your mom just said you guys drove a lot and went to some soccer games. Yeah.
I feel like we should have nap time in middle school.
If I don't get to nap, you don't get to nap.
Exactly.
Okay.
That's
You
why
can
I think
nap
that
right now
we
while we
all
nap.
should have nap time.
I like to keep my job.
Like,
Okay.
It doesn't become like a blue pot.
What if both of the markers that I pull out are blue? So the first one would be 12 out of 25. And then the second one, my numerator and denominator are going to be affected. What? 11 out of 24. Good. Okay, I want you guys to try the both yellow probability by yourself. So remember that once you take one of the yellows out, it's going to affect how many yellows are left and how many actual markers are left. Mia, do you need me to hold on to your phone for you?
No, I was trying to look at the pictures this week.
Isn't that my mom's Facebook? What?
Yeah, no, that's terrible. Thanks. Okay, how many people got 1/20th?
I did.
Good job. Excellent. Zoe, how'd you do on that one? But you're getting there? You on the right track?
Yeah.
Good. Miley?
Yeah.
Got it?
Can I get the answer? Like,
You got the two things?
yeah.
That's half the battle. Okay, now we have a bag that contains, have you guys ever seen Powerball drawing where they shoot the little ping pong thing out that has the number on it?
Yeah. Can I get my
Can you play bingo?
Kind of like bingo. Yep. Right? They spin it and they draw one, or they have one that just shoots it up like a tunnel.
Yeah.
Okay, so we have 16 ping pong balls numbered 1 through 16. 1 is drawn and not replaced. Underline that, highlight it, whatever you need to do to draw your attention to the not replaced situation. All right, what's the probability first of getting an even number? 8 out of 16, which is 1/2. And then how about an odd number? The first one is not replaced. 8 out of 15. 8 out of 15. There's 8 odd ones left, only 15 left.
You said it's not replaced.
Yeah. So if I take out an even number, that means my total now is only 15 left. But there's still 8 odd ones. So that's going to be 4 out of 15. Okay, this next one's kind of tricky. What's the probability of getting a number 10? 1 out of 16. What's the probability of getting an even number?
8 out of 7. 8 out of 15. 8, 14.
7. Why 7, Hannah? 10 is an even number, so that one's gone. So I only have 7 even numbers left out of 15 total. Oops. And so you end up with 7 out of 240, which cannot be simplified. All right. What's the probability of getting less than 13? 12. There's going to be 12 because we're not going to count that number 13 in there. So there's going to be 12 out of 16. And then what's the probability of getting the number 16? 1 out of 15. Three out of 80 cannot be simplified. Yeah, I cross-simplified the 12 and the 15. Last one, both multiples of 5.
Wait, wouldn't that be 4? If you're dividing by... No,
Oh,
if you're dividing 12 by 3, wouldn't that be 4?
it would be 4. Addison. So we have 4 out of 80, which can be simplified to 1/20. Nice, thank you. Are you like, no problem? Anytime?
Too smart.
Okay, how many multiples of 5 do I have? 3. It's going to be 2 out of 15. I only have 2 left out of 15 total. One out of 40 chances. Okay, so now what you're going to do is I'm going to give you guys a pink packet. You do not write on the pink packet. You use it with your partner, no more than 3 people working together. And then you're also going to get a white piece of paper that you and your partner and or partners will put your names on, and you put your answers on that white piece of paper. 1 pink packet, 1 white piece of paper for each group. If you want to work alone, that's fine. Does anybody have questions?